Okay, looks like you just did a little reading about prime numbers and composite numbers, and notice that prime numbers are a number like 17, because the only way to get 17 is equal to 1 times 17, where a composite number is a number that has more factors. So let's take a number like 30, because I know 30 can be 5 times 6, right? And I know 30 can be 2 times 15. So there are options other than just 1 times 30. 1 times 30 is an option, but not the only option of a composite number. So in this slide, it talked about prime factors and prime factorization. And what that really means, hang on here, is looking at breaking a number down to just the prime factors, those numbers that are not composite numbers. So if I take 420, I have a number of options, right? But I know it looks like it's divided by 2 easily. So I could take that and say it's 210 times 2, right? And I can say, well, 2 is a prime number. 1 times 2 is the only option. 210, it looks to me like it could be divided by 2 again. So 2 times 105, that one I cannot do anything with. And it builds a bit of a tree with branches. That's why it's called a factor tree. Again, 2 is nothing. That looks like 5 times 21. Okay. And then the only one left, 21, has still got options. So that's 2, that's 5, 3 times 7, and that's 2. So 420 can break down into the factors of 2 times 5 times 3 times 7 times 2. Now I could have done it differently. I could have started by dividing by 7, started by dividing by 5, or started by dividing by 3, and the factor tree would look a little different, but you'd end up with these same factors down the bottom. So that's really what they're talking about with factor trees and prime factorization.